xy equals k, where k not equal 0. Okay? We can put this inverse variation or the equation of inverse variation in another type like y equals k over x. So, inverse variation, we can put it as xy equals k or y equals k over x. Let's take an example about inverse variation. If y varies inversely with x, y equals 8, when x equals 3, find the equation and find value of x when y equals 12. Like you see here in the equation of inverse variation, x and y are variable. K will be constant. So x, we can't change x or y. They are variables. Okay? But k is a constant. Let's take this equation and put it here. Okay? So we have xy equals k. We have y equals 8 when x equals 3. So just substitute y equals 8 and x equals 3 in this equation. So it will be 3 multiplied by 8 equals k. Okay, so 3 multiplied 8 equals what? Yes, it's 24. Good. So k equals 24. So we can write this equation of this variation like this. X, y equals what? Yes, equals 24. So the equation of this variation will be xy equals 24. Okay? Okay. Let's complete that question and find value of x. Find the value of x when y equals 12. So it's inverse variation like we see. Okay? So just substitute by x and y equals 12 in this equation. Okay? So x, I have it x. So I put it as x. Multiplied by y. Y equals what here? 12. 12b equals what? Yes, 24. So divided by 12, yes, each side. Divided by 12 here, divided by 12 here. So x will be equals 2. Okay? We can solve this question by another way. Okay? This is two steps. This is the first step and this is the second step. We can solve this question just in one step. Look at this. We have here, if we want to just get value of x when y equals 12, and we have y equals 8 and x equals 3 without finding the equation. So how to get this? We can just write this equation. Okay, I write it here first. x1, y1 equals x2, y2. So x multiplied y1, x1 multiplied y1 equals x2 multiplied by y2. Okay, we can do it like this? Yes. So we have here x1 equals 3, y1 equals 8, and I need to get x2 when y equals 12, y2. So write the equation x1, y1 equals x2, y2. Is it clear? I think it's clear. So just substitute by x1 equals 3 and y equals 8. So it will be 3 multiplied by 8 equals, yes, x here, I don't have x, so I put x2 multiplied by y2, which is equal to 12. So just multiply 3 multiplied by 8 divided by 12 to get x2. So x2 will be equals 3 multiplied 8 divided by 12. 3 multiplied by 8 equals 24, divided by 12, 12b equals just 2. Okay? So, this is inverse variation. Okay. About inverse variation, or about this equation, how to graph this equation? How to graph inverse variation? Look at this. If I have x-axis and y-axis, okay? This is the origin point, of course. 1, 2, 3, 4, and so on. Negative 1, negative 2, negative 3, negative 4. Up. 1, 2, 3, 4, down, -1, -2, -3, -4, and so on. Okay. Okay. So we have here, like you see, y equals k over x. K over x. I put an equation like this. Y equals -2 over x. Another one, y equals 3 over x. Another one, y equals 3 or 2 over x plus 2. Let's see this. To draw each one of them, okay, if it's the origin 1, if it's y, just y, equals 1 over x, look at this, it will be drawn by a smooth line, doesn't intersect with y-axis here and here. If you just make a table, x and y, okay, and substitute by numbers like 0, 1, 2, 3, -2, -1, and so on. Just substitute by these numbers or another number. It will be drawn like this. The two lines, okay. What about this? Y equals -2 over x will be the same. The same thing. Also, this one, but if it's -2 here, look at this. K is smaller than 0. So, in the first equation, we have k greater than 0 equals 1. But here, it's smaller than 0. K smaller than 0. It's -2. So, if it's positive, it will be in the first quadrant and the third one. Okay? If it's positive, if k greater than 0, it will be drawn like this in the first quadrant and the third quadrant. Okay. What about if it's negative number like here? It will be drawn in the second quadrant and the fourth quadrant. It will be drawn like this. It will be drawn like this. So if k greater than 0, it will be drawn in the first quadrant and the third one. If it's -2, if it's smaller than 0, so it will be drawn in the second quadrant and the fourth quadrant. Okay? About this equation, of course, it will be drawn like this. In the first quadrant and the third one. Why? Because k equals 3. 3 is bigger than 0. Okay? Okay. Let's take this one. Y equals 2 over x plus 2. Okay guys, so we will start inshallah with 4. Y equals 1 over x minus 3. If you look at this question, the excluded value here equals what? Excluded value, that the value we can't substitute with it. Yes? I hear this. So we will put x equal what? 3. This is the excluded value. How to get it? It's alright. X minus 3 equal what? Equal 0. So can't be the denominator equal 0. So this value, which is x equal 3, is the excluded value. We can put it equal 0. So we have something new now, is the vertical asymptotes. The vertical asymptote. What the meaning of the vertical asymptotes? When x equals 3, where is x equals 3? All of you know this, x here equals 0. This is y-axis, x equals 0. Of course, this is x-axis, y equals 0. So x equals 3 will be here, yes, straight line parallel to y-axis and intersect with x-axis at 3. Okay, so this is the excluded value that our function y equals 1 over x minus 3 can't intersect with this one. So if we draw this by doing the table, you will look at this, it will be like this. Okay? So the graph of y equal 1 over x minus 3, because the excluded value x equal 3, so the graph will be translated to the right 3 units. 1, 2, 3. Okay? So the excluded value, we draw the vertical asymptotes. This line called vertical asymptotes. Okay? Okay. Let's go to question 5. 5 here we have y equals 1 over x plus 3. 1 over x plus 3. Okay, what about this? Of course, the excluded value here, x equals 0. So we will use this, will be, x equals 0, will be what? Will be the vertical asymptote. What about this 3? This 3, okay, will be the horizontal asymptotes. The horizontal asymptotes. How? If this point equals 0, so the horizontal asymptotes will be equal, yes, y equals 0, but it's equal 3. So the horizontal asymptotes, it's a line parallel to x-axis and intersect with y-axis at this point, which is 3. Let's proceed our questions. So question 4, we want to graph this function, y equals 1 over x minus 3. Y equals 1 over x minus 3. When it was y equals 1 over x, we have something here. Our graph was like this and doesn't intersect with y-axis because x equals 0, which is the y-axis, is a vertical asymptote, something like a vertical asymptote that can't be just approaches to this vertical asymptote and doesn't intersect with. Okay, if it's 1 over x minus 3, so we will get something called excluded value, that the value can't be, yes, in the numerator here, because it's 1 over x minus 3, can't be the numerator equals 0. We can't divide by 0. So x here equals what? The excluded value. So put x minus 3 equals 0. So x will be equal 3. So this is the excluded value. Okay? So in this function, or in this variation, y equal 1 over x minus 3. So if x equal 3, it will be undefined. We can divide by 0. Okay? So the vertical asymptotes will be a straight line parallel to y-axis and intersect with x-axis at this point, which is 3. So our graph will be like this. Because our graph can't intersect with this point. Okay? Okay. This is about the vertical asymptotes. So the vertical asymptotes, we got it from where? From the numerator here. Put the numerator equals 0. Okay? So get value of x. It will be the excluded value. This excluded value will be, x equal 3, will be a line called vertical asymptotes. Okay, let's go for question 5. Question 5, y equal 1 over x plus 3. Out of the fraction, plus 3. What about this number? If you look at the main equation, y equal 1 over x, we can put it like this. We can put it here, like here. Y equal 1 over x plus a plus b. A will be the vertical asymptote that we will take it, okay? Of course, we will put it equal 0, so it will be x plus a equals 0. So x will be equal negative a. So this is the vertical asymptote. About this point, or this number b, beside the rational function b, b will be the horizontal asymptotes. The horizontal asymptotes, okay? If b equals 0, so the horizontal asymptotes will be what? Will be x-axis, which is y equals 0. Okay? Okay. If I have here a number like this, 3, so I have another horizontal asymptotes. It's not 0, it's a 3. So where is y equal 3? Why is it? Yes, it's a straight line parallel to x-axis and intersect with y-axis at 3. So I can draw it like this. So this is y equal 3. So y equal 3 is a horizontal asymptotes. Okay, we can draw it now. It will be like this. So it's translated up. How many units? 3 units. 1, 2, 3. Of course, we have here, like you see, horizontal asymptotes, y equal 3, and the vertical one is just x equal 0. If I put here a number like minus 2, so I have a vertical asymptotes that x will be equal 2. So the vertical asymptotes, I can here put it like this, a straight line, intersect with y equals 0, it's x-axis, okay, and parallel to y-axis. So our graph, if it's 1 over x minus 2 plus 3, it will be drawn here.